All right, so we've got a few log properties we're going to talk about in this video. And I've got 4 examples, well actually 5 examples, but the last 2 are kind of a similar property. And so what we're going to do is we're going to explain how to do all 5 of these examples, and then we'll talk about what's the general rule. So our first example is if we have log base 8 of 2 plus log base 8 of 32, what's that going to be? Now you could, figure out what each one of these is in this case. They're going to be some fractions, but there is a shortcut to this as well. And that is if we have 2 logarithms that are added together and they're the same base, we can write that as one logarithm. So that's going to be log base 8. And then what we do is the number that we're taking the log of, since they're added together, we multiply those two. So this ends up being 2 times 32, which is log base 8 of 64. And so if we're trying to figure out what that is, we can do our old zoop trick where it'd be 8 to what power is 64, so just convert it to an exponent. So that means that this equals 2, because 8 squared is 64. So what's the general rule? It's called the product property. And if you have the log base b of m times n, you can break that up into log base b of m plus log base b of n. Or, like we looked at with my example, if you have 2 things that are the same log base added together, you can go the other way and multiply the 2 things that you're taking the log of. In this case, it's m and n. Okay, so that's the first log property. It's called the product property. If you're taking notes, feel free to write that down and pause the video. Let's look at example 2 here. So this one's very similar, except in this case, if you notice, we're subtracting instead of adding. And so log base 3 of 36, that's not something that we could figure out without a calculator. And log base 3 of 4, once again, you would need a calculator to figure that out. And not all calculators have a log base 3 option. All of them have a log base 10 option that's a scientific. So we'd have to do a little finagling. But what we can do is we can combine these 2. And since it's subtracted, this becomes log base 3 of 36 divided by 4. And so when you have the same base, in this case it's 3, you take the 2 things that you're taking the log of, in this case 36 and 4, and you divide those 2. So this becomes log base 3 of 36 divided by 4 is 9. So this is really saying 3 to what power is 9? Well, that's to the 2nd power. So this ends up being 2 again. So what's this property called? This is called the quotient property. It says if we have the same base and they're subtracted, you can combine them to just dividing. So it's exactly what we looked at. This is called the quotient property. Okay, let's look at the third example. Here we have log base 5 of 25 to the 3rd power. And so what I'm going to do is I'm actually going to call on the first property we looked at. This is really log base 5 of 25 times 25 times 25, because it's 25 to the 3rd. Well, what this is, since we know that if you have things multiplied together, you can split them up. And so this really becomes log base 5 of 25 plus log base 5 of 25 plus log base 5 of 25. Well, really what we have is 3 of these things, right? We've got 3 log base 5 of 25s when we split it up like that. So the shortcut that you often will hear is we'll just take this exponent and pull it out in front, and this becomes 3 times log base 5 of 25. Well, that's kind of what we just proved here, right? Is we broke it up into 3 different log base 5 of 25s. So you can look at it either way. You can either write 25 3 times like we did there, and then split it up into 3 logarithms. Or you can pull that exponent out in front like we did here, and then you just do 3 times whatever log base 5 of 25 is. So if we look at log base 5 of 25, that's really saying 5 to what power is 25? Well, that's 2, so maybe you're seeing this theme here. That's 3 times 2, which is just 6. So this is another log property. This is called the power property. And this is basically saying if you have an exponent on a logarithm, you can take that exponent and pull it out in front. And so if you have log base b of a to the 4th, that is the same as 4 times log base b of a. So it'd be 4 times log. I'm not going to write them all out, but that's basically what we looked at. So this is called the power property. If you have an exponent on a logarithm, you can pull that out in front and then evaluate the log from there. So you don't have to do 25 to the 3rd like we saw in the beginning. Instead of figuring out what 25 to the 3rd is, you just pull that exponent out in front. Okay, last examples here. Examples 4a and 4b. Well, 4a is very, very similar to the one we just looked at. If we have this exponent, we can pull it out in front. And we've got 55 times log base 4 of 4. So the thing I want you to notice about this example is that the base and the thing we're taking the log of are the same. And so this thing right here, log base 4 of 4, is saying 4 to what power is 4? Well, that's just 1. So we've got 55 times 1, which is 55. So the shortcut here is if the log base and the number you're taking the log of are the same, then the answer is just that. So it's just 55. So that's the first one. The second one is example 4b over here, and I'm just going to write this as equals x. And so if I had, let me just do a quick side example. Let's say I had 2 to the y equals x, and I wanted to write that in log form. It would be log base 2 of x equals y. And if I always kind of second guess myself here, and then I'll do the zoop to see if that is correct, and it is 2 to the y equals x. So I did convert that correctly. So what I notice here is the 2 is the base of the logarithm. And so I'm going to do the same thing up here. I'm going to do log base 6, because that's, the 2 is basically the same as the 6 here. And then this exponent acts as the y in this example. And so this is going to equal log base 6 of, let me do that again. I did not give myself enough room there. Log base 6 of 13. So that's like our y in this side example we did here. And then that equals x. Well, in this case, we just called it x, and so this would be, well, not equals, excuse me. We'll just put an x here. So what is x equal? Well, if this is log base 6 of x, and this is log base 6 of 13, then that means this is just going to be 13. So a lot of times you'll hear teachers say, or people explaining logarithms to somebody, they'll say, well, if you've got 6 to the log base 6, that basically cancels out, and then you're left with just 13. Not exactly, but if you want to think of it that way, so be it. So the answer is 13, but this is the explanation of why. We convert it to a logarithm, and you get x equals 13 in this example. So these are both called exponential-logarithmic inverse property. And so basically it's an exponent inverse situation. And those are the two properties. So there's 4 properties that we talked about in this video. We talked about the power property, quotient property, What was the third one? What did we call that one? Oh, that was the power. What was the first one called? Product. Product, quotient, power, and then this is called exponential logarithmic inverse property. So those are the 4 properties you need to know from this video.